Hello, this is a presentation for project on the simulation of cryptocurrency. So first let us start by running the command mix.phx.server. This will start the server and then all the simulation is happening on the background. So while the data is accumulated into the DB tables, let us first look into the project structure that we have. So this is the project here, and then here within the library folder we can see the entire project structure here. So we have the controllers here, and then the templates are all maintained in the templates folder. So if we go into the templates and then check the pages, we have templates for mining, transactions, and wallets. And then the controller here, the controller, all the operations are then defined in the controller here, and the core business logic is maintained in this core folder. So here you can see that we have a number of ex files, each of them representing a module such as block or the miner or the transaction module. Going into each of these files, so this is the initial file where the simulation starts. So the number of miners is set to be 100, and then for each of the miners the wallets are initialized, and then the transactions are initiated, and then the mining also begins here. So in the mining, we can see that the proof of work is done, and then the mining is spawned for all of the 100 miners, and then whoever first comes up with the block, they are considered to be the winner, and then they are awarded with 10 bitcoins. And then if we go into the and then each of the participant in the network is created with using a join server. So here you can see that there are a number of functions that are defined. So uh, we, we can see the mining function that is defined here, where the participant performs the proof of work. And then if we come into the transaction module, you can see that we're validating the transaction based on the private and the public keys. So this is how the business logic is defined in the project structure. And then and, and then that once the mining is complete, the transaction is completed. And then we can also see the other modules that we have. So we have the block. This is the structure of the block that is defined. The Merkle tree is defined this way, and then the wallet is defined here, where we can see the private keys and the public key using the electric curve. Now coming into the Phoenix framework, so first let's look into the database schema that is created. So to communicate with the Phoenix app and serialize the data, we have the following schema. So there is a table that is maintained for the wallet information, where all the private key, public key, the number of bitcoins that the participant currently has, information is stored. And then the transaction table, where each of the transaction that happens in the network is stored, followed by a mining table where all the mining information is stored, such as the miner, the number of coins that was mined, the time it taken to create one new block, and so on. Now, the server is running, and let's go and run the local host and see how the UI framework looks like. So this is the landing page, and here you can see the various modules that we have. So we have named our cryptocurrency as Dravidium, a cryptocurrency that you can depend on. So this is a project by Harkirat, Singh, Lamba, and Srikanth Bharadwaj. So the various modules are represented here. So let's go into each of them and then see what are the stats that we can see. So if we navigate into the wallets module, you can see that there are 100 users, and the amount that is there in each of the wallets are represented through this scatter graph. So if I hover over any of one of them, so the user 41 currently has 1003 coins, and then if we go into 58th user, they have 1041, and on the contrary, if we come into the 93rd user, he has 955, which basically shows the scattered which basically shows the scattered amount of coins that are held by each of the participants. So this graph here represents also the transactions that has happened. So at a given point, maybe the 55th user has done a transaction with the 58th user, so that then a number of bitcoins from 55th user is transferred into the 58th user. Then going back into the home page, now we look into the transaction module. So here you can see the stats on the transactions that has happened. So this graph represents the sender and the number of bitcoins that has been sent by the particular user. So each of these PIDs represents a user within the network. So we can see that the user 459 has sent about 7 bitcoins. Similarly, user 675 has sent about 10 coins. The graph below here shows the other side of the transaction, where it shows the receiver and the number of bitcoins that has been received. So PID 456 has received 10 bitcoins, PID 440 has received about 6 bitcoins, and similarly PID 671 has received about 1 bitcoin so far. And now going back into the home page, if you look into the mining module, this graph here, a pie chart, represents the number of times the given user has mined. So from this graph you can see that 458 user has mined about 10 times. Similarly 450 has about 10 times, and this graph gives the count of each of the user, the number of times that has been successfully mining. So from this graph we can also see the user who has done the highest number of mining. So we have 3 users with 10 count. So these 3 users have been quick in their proof of work, and then they have been able to successfully perform the mining. And then this graph here shows the amount of time taken to do individual mining, or the time taken to create a new block. So when for the time taken here, it is in terms of milliseconds. So the user 457 has taken 336 milliseconds to perform the mining, while the user 453 has taken about 4000 milliseconds. So the mining is done by computing the hash. So this time here basically represents that more time has been taken to compute the hash and then identify the ones. So each of these time here represents the amount of milliseconds that has is been taken to create a new block. Thank you.